And welcome back, everybody. We're still talking about solving quadratic equations. So far, we've solved by graphing, square roots, factoring, and completing the square. So our last method is using the quadratic formula. Remember, we're talking about ax squared plus bx plus c is equal to 0. When we have that, then we have the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now, y'all know that we don't ask you to memorize a whole ton, but you do need to know this formula for your chapter test. Be careful of your signs. Can't stress enough how super important it is that you pay attention to your positives and negatives. One thing that always comes up is this b squared in here. When you square your b value, that should always be positive. Don't forget to simplify your radical as much as you possibly can. And before you even get started, make sure the equation is equal to 0. Before we get solving, let's talk about the discriminant. The discriminant is the radical part of the quadratic formula. So it's the stuff right underneath that square root. This is important because it can tell us how many answers and what kind we should have. This will be a question on your test. It will be a question on your final, and it's a question on ACT. So if your discriminant is positive, let's say you had radical 10. That's a positive 10. That means there are 2 real roots, solutions, zeros, x-intercepts. If your discriminant is 0, meaning you have the square root of 0, then there is only 1 real root, x-intercept, solution, and it's not necessarily 0. And last but not least, if your discriminant is negative, meaning you have like a square root of -8, then there are 2 imaginary or non-real roots. So let's try some solving. Again, the very first thing we want to do is make sure that we have standard form and that it's equal to 0. Our first problem here is not equal to 0. We have this x minus 3. So we're going to move our x and our 3 over to the left with their like terms. This is a positive x, so we will subtract x from 8x. This is a positive 3, so we will subtract 3 from 5. These add to 0, so I now have 0 on the right side. And we have 4x squared minus 9x plus 2. Now I can label my a is 4, my b is -9, and my c is 2. Please make sure you know the a, b, and c are only the numbers, not the x's and the x squareds that are there with them. Now I can plug it into my formula. So we have -b, which is -9. Actually, I'm going to slide this over so I've got room. So x equals -b plus or minus the square root of -9 squared minus 4ac all over 2a. I'm going to start over here. The -9 becomes +9. plus or minus. The negative 9 squared is a positive 81. So we have 81 minus 4 times 4 is 16. 16 times 2 is 32. So the square root of 81 minus 32, which is going to be 49, all over 2 times 4 is 8. Well, 49 is a perfect square. It's 7. And so we have 9 plus or minus 7, all divided by 8. So to find that solution, I'm going to do two problems. I'm going to do 9 plus 7 over 8 and 9 minus 7 over 8. 9 plus 7 is 16, and 16 divided by 8 is 2. 9 minus 7 is 2 over 8, which reduces to 1/4. So my x-intercepts, zeros, roots, or solutions to this problem are 2 and 1/4. All right, example 2. This problem is also not equal to 0. So we can do one of two things. We can move all of this over with the 3, or we can move the 3 over to the x squared and the x. It doesn't matter which way you go, you get the same answer either way. So I'm going to go ahead and move that 3 over here. Remember, it doesn't have a like term, so we slap it at the end. And now we have 0 is equal to negative 2x squared plus 4x minus 3. This is standard form. I have my A, my B, and my C. So plugging that into quadratic formula, we have negative B plus or minus the square root of B squared minus 4 times A times C. Again, be very careful that you keep the negative with the 2 and the negative with the 3. And this is all over 2 times negative 2. So the negative 4 on the outside stays negative 4. Here we have 16. I have 1, 2, 3 negative signs. So that's going to be overall negative. 4 times 2 is 8. 8 times 3 is 24. So I have the square root of 16 minus 24, which is negative 8, over 2 times negative 2 is negative 4. I'm going to go ahead and say negative 4 over negative 4 is a positive. And then I need to work on that radical negative 8. So remember, we can change that into the square root of negative 1 times the square root of 8. The square root of negative 1 is I. And even though 8 isn't a perfect square, the initial part of this says make sure that you simplify as completely as possible all your radicals. So I'm going to break down the 8, and we have a pair of 2's that's going to come out, and this 2 that gets stuck under the radical. Wow, there's not a whole lot else I can do to clean this up except to say this is a fraction, and do I have anything that has common factors? Now remember, I can't count the radical because it's not a like term, but I can say that this 4, this 2, and this 4 all have a common factor of 2. So when I reduce that, we get 2 plus or minus 1i rad 2 over 2. And that is going to be our final answer. Our last example tonight is this one. And I see that it's equal to 0, but I also see that we're missing something. So if I want to use quadratic formula, I have to have all three terms, A, B, and C, and my C term is missing. So we can go ahead and add a 0. Since it's not there, 0 means nothing. And now I technically have A, B, and C. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So our negative 15 becomes positive 15. Inside our radical, we have negative 15 squared, which is positive 225, minus 4 times 2 times 0 is 0. So 225 minus 0 keeps 225 under that radical, and 2 times 2 is 4. Well, 225 is a perfect square, so we have 15 plus or minus 15 over 4. Again, because we have no radical left, that means we're allowed to go ahead and do that math. So I have 15 plus 15 divided by 4, and 15 minus 15 divided by 4. This is 30 over 4, which is 15 halves, as one of our zeros, roots, solutions, x-intercepts. And then 15 minus 15 is 0 over 4, which is 0. And even though it's 0, it still does count as an answer because I can plot x is 0 on a number line and on a coordinate grid. So 15 halves and 0 are my final answers. Stay tuned tomorrow for some other tips and tricks on completing the square and the rest of our solving information. Have a great night.